I know most of us has already encountered the word energy and knows what it is. And maybe there are a lot of things that comes into to our minds when we hear that one. However, it's like a fuel or maybe a power enable for us to move. As a true definition, according to science, energy is the ability to do work and cause change. In physics, it's the property of matter and radiation which is manifest as a capacity to perform work. It is called as a property of matter simply because matter is anything that occupies some space and mass. It's said that when there's a matter, there's an energy. It's because the two are closely related to each other. How? Due to mass and energy equivalence, where when the object's total mass will increase, the object's total energy will also increase. Energy is a conserved quantity. It comes from the Greek word energia, meaning activity. In 4th century BC, the word energy appears at Aristotle's works. James Prescott Joule is the scientist of energy where the unit of energy come from, the joules. And the father of energy is Nikola Tesla. In energy, there is also so-called the law of conservation of energy that is proposed by Emily de Chatelet. It states that energy can be converted in form, but not created or destroyed. And in able to convert it, Albert Einstein discovered an equation that is also so-called Einstein equation, which is energy is equal to mass or rest mass, multiplied by the c squared or the constant. Its purpose is to measure an amount of energy created when the nucleus is created from fusion or fission. His formula has a limitation. You can only use it to compute energy released, but you cannot use this for particles traveling at extremely high speeds. And when it happens, it goes to another equation. Now let's tackle its different types. First and second are potential or stored energy and kinetic or energy of moving objects, which is representing as the main forms of energy. The summation of two is called mechanical energy. Thermal energy or heat energy is the total of energies of the atoms in the object or in an object. The energy that we hear is so-called sonic or sound energy. Nuclear energy is an energy that is stored in the nucleus of an atom. Gravitational energy is an energy that is stored in an object when it is above the Earth's surface. Energy is stored in chemical bonds and released by chemical reactions. It is called chemical energy. Electromagnetic energy is an energy that travels in waves. And the last but not the least is ionization energy, an energy needed to remove an electron from an atom. Now that we know its different types, now let's talk about the importance of energy. For us, there are two majors or general importances of energy. First in the line is energy serves as a basic need of all living things or creations on earth, like food, water, nutrient, gravity, and many more. Why? Simply because, for example, in nuclear energy, sun is the most important of energy resources. It helps our basic foods to grow like vegetables and fruits, where we can get the important nutrients that our bodies needed in able to have a healthy living. Number two is it makes our life easy, comfortable, and convenience like fire on woods. Fire on woods is an example of thermal energy where through this we are able to cook our food. And also machineries that helps us for easier cook food or even in factories and makes our job easily. I hope in these two importance will under everything that running in your minds. So let's move on. Now, as an application, we will be trying the Einstein equation through the help of my group mates, and they will show you how to solve it.
Good day, I am Cristine Joy Alvarez from BS Psychology 2F. This is the formula of energy. E equals mc square. E is means energy, M is means mass, C is the speed of light. This is the problem solving number 1. What is the energy equivalent of 1 kilogram of matter? The speed of light is 3 times 10 to the power of 8 meter of seconds. This is the given. Mass equals 1 kilogram and the speed of light is 3 times 10 to the power of 8 meter of seconds. This is the solution. 3 times 10 to the power of 8 equals 9 times 1 equals 9. The solutions of 9 times 10 to the power of 16 is mc squared. 3 times 10 to the power of 8 square root times 1 equals 9 times 10 to the power of 16. The answer is A. mc squared 1 3 times 10 to the power of 8 square root equals 9 times 10 to the power of 16 joules. And the problem solving number 2 is what energy is obtained which a 10 kilogram of mass is completely converted into energy. The speed light is 3 times 10 to the power of 8 meter of seconds. Given is mass equal 10 kilogram and c is the speed of light is 3 times 10 to the power of 8 meter of seconds. This is the solutions. 3 times 10 to the power of 8 square root equals 9 times 10 equals 90. The solutions of 9 times 10 square root of 16 times 10 equals mc squared 3 times 10 to the power of 8 square root of 2 times 10 equals 9 times 10 of, of the power of 17. The answer is A equals mc squared 10 3 times 10 to the power of 8 square root of 2 equals 9 times 10 to of the power of 17 joules.
Good day. I am Denice Caasi from BS Psychology 2F. So here is the formula of energy. E equals mc squared. E means for energy, m is for mass, and c the speed of light. And now let us solve the problem. Okay, this is the problem number 1. Suppose 2 grams of water could be completely converted to energy. How much energy would be produced? C equals 3 times 10 to the power of 8 meter per second. So this is the solution number 1. Here is the given in the problem. Mass equals to 0.002. By the way, we convert 2 grams into 0.002 kilograms. So now, I have here my answer, but in order to solve the problem, we need to use scientific calculator. Um, okay, I will show you how I solve the 1.8. So the solution is 3 times 10 to the power of 8 equals x squared equals 9 times 0.002 equals 1.8. And then solve the 10 to the power of 14. So the solution is mc squared equals 3 times 10 to the power of 8 squared times 0.002 equals 9 times 10 to the power of 16 times 0.002 equals 1.8 times 10 to the power of 14. So so the answer is E equals mc squared equals 0.002. 3 times 10 to the power of 8 squared equals 1.8 times 10 to the power of 14 joules. Okay, this is the problem number 2. According to Einstein, how much energy is stored in a 5 kilogram object? The speed of light is 3 times 10 to the power of 8 meter per second. Here is my solution number 2. Here is the given in the problem number 2. Mass equals to 5 kg and the speed of light is equals to 3 times 10 to the power of 8 meter per second. I have here my answer, but before that, I will show you how I solve the 4.5. So the solution for that is 3 times 10 to the power of 8 equals x squared equals 9 times 5 equals 4.5. And to solve the 10 to the power of 17, the solution is mc squared equals 3 times 10 to the power of 8 squared times 5 equals 9 times 10 to the power of 16 times 5 equals 4.5 to the power of 17. So here is my answer. E equals mc squared equals 5. 3 times 10 to the power of 8 squared equals 4.5 times 10 to the power of 17 joules. And now, let's listen to Mr. Callao.
Good day, I'm Jayvee of BSI 2F, and I will show you how mass and energy is relative and show you how to use their formulas. I'm gonna show you how to use E equals mc squared. First, let's find the mass, which is 0.25 kg, and since there's no given speed, we will use the 3 times 10 to the power of 8 meters per second. Then apply it to the formula. It should look like this. When you square the speed, just the first number and the exponent only, because the times 10 is a fixed number in scientific notation. So 3 times 3 is 9, and 8 times 8 is 16. So just copy the times 10, and you will have 9 times 10 to the power of 16. Since we cannot multiply scientific form by real numbers, like the 0.25 kg, we need to convert it to scientific notation form. Just put a dot on the first whole number, just like this red dot, which is 2, and you will have 2.5 times 10 raised to the power of -1. But why -1? Because our real number is less than 1, so we will count the numbers ahead of the 2, and there's only 1 0, so our exponent is only -1. Since we have now two scientific forms, we can now multiply it. Just multiply the first number and subtract the exponent. Again, we cannot change the times 10 because it's a fixed number. So 2.5 times 9, which is 22.5, and -1 minus +16 is 15. But there is a rule that first number cannot be above 10 because the value will not be correct. So just move the dot one step ahead and just plus 1 in the exponent. So we will have now 2.25 times 10 raised to the power of 15 plus 1, which is 2.25 times 10 raised to the power of 16 joules. In this problem, we will use the formula M equals E divided by C squared. First, let's find the given energy, which is 7 gigajoules, but we need it to be joules only. Just multiply the 7 gigajoules to 1 trillion, and we will have 7 trillion, and convert it to SN form. When we convert it to SN form, just put a dot on the first whole number, which is 7, and just count the numbers before the dot, which is 9 zeros, and the 9 will be our exponent. So it should look like this: 7 times 10 to the power of 9. Since there is no given speed, we will use again the 3 times 10 to the power of 8 and square it. The same result like the recent problem, and just divide these two SN form. When dividing, just divide the first number of the SN form and subtract the exponent. So 7 divided by 9 is 0.7 something, and 9 minus 16 is -9. So since we have less than 1, we will move the dot here and add plus 1 on the exponent, and the result will be this: 7.7 something times 10 to the power of -8. So that's how you convert energy to mass and mass to energy. That's all for my presentation. Before we come to an end, here are some key takeaway notes that may help you in the future. So, we are group assigned in energy. We hope you learned something from us, and we'd like to thank you for your time, interest, and cooperation. And have a nice day, and thank you once again.